Welcome to episode 4 of the Welding Codex. In this episode, Pete and I pick up where we left off in Clause 3 of AWS D1.1 Structural Welding Code. This is the clause that lays out how an individual would write a pre-qualified welding procedure. Right now, we're going to dive into where our conversation was, and we were discussing pre-qualified weld joints and their effect pre-qualified welding procedure specifications, pre-qualified WPSs. This podcast is for those who want to learn more about the technical side of welding. We're going to talk philosophy of welding, welding codes, welding defects, and topics like that. My name is Gary Pace. I'm a welding engineer, and the other two hosts of this program are Peter Kinney and Joel Christie. Both are Ohio State welding engineers. All right. What do you got on weld joints, Pete?
Well, they're not the kind of joints that other people are thinking they might be.
We're not talking Colorado, Washington, Nevada, anywhere where it's gone full wreck.
That's right.
So to do a pre-qualified weld joint, when they're talking about joints, if you look at AWS D1.1, is very limited in regards to the welding joints that you can use when you're writing a pre-qualified weld procedure. There's a whole bunch of pictures that tell you what kind of weld joint you can use with any particular welding process. So there's pages and pages of them. So when you're writing a pre-qualified weld procedure, a lot of times you might just want to use one specific weld joint and call it good, as opposed to using 15 different ones. Where are you at with the weld joints, Pete?
Yeah, you got different kind of joints, and I think we can kind of break them down into a couple simple ones. We got CJP, which is an acronym we've used a lot, and I think we've defined it in our earlier session, but complete joint penetration. We have those. We have partial joint penetration, which basically you have a 1-inch thick plate, but you're only welding, let's say, half of it or a quarter of it, or hey, it might only be like an 1/8 weld all the way around just so water doesn't get inside. Those are, and then fillets are the main kind of joints that we have. But going back to our CJPs, for pre-qualified, you have to have it either backing using steel or it has to be back gouged. That's the only way you can have a full penned weld under pre-qualified D1.1.
And by back gouging, we mean that you weld it from one side and then you come in from the other side, the root side of that weld, and you chew out a whole bunch of weld metal or base metal and weld metal till you get it to sound metal, and then you weld it out from that side. So you're welding the joint out from both sides. So when you're back gouging, you're digging in there from the non-welded side and taking out material till you get down to clean metal, and then you weld it up from that side. That's what we're talking about when we're talking about back gouging. You can't
Correct.
just put in a 60-10 root like you would on pipe and then fill it out with 70-18. You got to go in and clean that other side out. So that's what we're talking about. You cannot have a weld joint that has been welded from one side with the pre-qualified clause and expect it to fly. It's prohibited.
Correct. And for the CJP and PJP, there are figures. Like, well, how do I come up with a weld joint? Where do I get these figures from? Do I just make them up? Gary, where do we get these joints from?
I'm on 2015, so I'm in figure 3.2, which I guess would be figure 5.2, but there is, I don't know how many of these, just numerous joints and configurations and there's little tables that tell you which weld procedures or weld processes you can use with those weld joints. I'm looking at 3.2 in 2015, and it's pre-qualified PJP groove weld joints. So you go in there and you look and find your configuration, what you're doing falls into one of those configurations. That's the weld joint you use, and they're all numbered. So they have joint designations like BP7, BP7GF, BP7S. It tells you which one. It varies by process. In these groove diagrams, they'll give you the thicknesses, groove preparation tolerances, base metal thicknesses that you can use them on, welding positions that are allowed. Obviously, some of these are for submerged arc welding, so they're only flat, right? You can't do it in the uphill position or the overhead. Miss anything there, Pete?
All right, so the 2020, it's figures 5.1 and 5.2. And if we were, as you said, like a joint designation, so like let's say if we just go on the first one, which this is a full pen weld, it's called a BL1A. We have one for stick welding here, or SMAW. You'll notice that in the drawing we have two base metals. We have a T1 and a T2. And basically, if we're looking at when it says T1 max, T2 would be the same. It gives us a root opening where it says R is equal to T1. So hey, we could have a root opening of let's say this material's 1/4 inch. So we can have a 1/4 inch root opening. And do we have these tolerances on here, Gary, detailed and as fit up? Can you walk us through?
Now you're going to make me work. I see how you are. Okay, so not having swam in this pool in a while. Okay, so you have the as detailed tolerance. So for which one were you looking at, Pete? What's the number?
That's a BL1A.
Complete joint penetration?
That's a complete joint penetration. This is where it's basically a square groove weld. And it is the simplest and easiest way to weld two, let's say, thin plates together.
Okay, here we are. So if we're going shielded metal arc, BL1A, the base metal thickness, we can go thickness. It can be a 1/4 inch maximum is the thickness for that one, for BL1A. So we're going to get our root opening. So the largest root opening we can have, because we're doing this one with backing, is the thickness of the material. So that's T1. So then we're going to go to the as detailed thickness for the tolerances, and it gives us +16th -0. So the detailer can detail this out, and he can have any of the tolerances. He can add a 16th, but he can't subtract anything. So for the root opening, he could add a 16th, but he can't make it any tighter.
Okay.
And then the as fit up, because once we get it out into the field, as fit up, you can add a 1/4 and subtract a 16th. So it could.
All right. So what you're telling me,
you could also have it plus a 1/4. You could have it a little bigger.
So you're saying if I accidentally cut my plate a little short, I could kind of split my difference, and I could make it where I have a root opening if I had a 1/4 inch plate, 1/4 inch root opening. Now, if I cut my plate 5/16 too short, could I increase my root opening by 5/16, or could I only increase it by a 1/4? If the as detailed plus a 16th, do I get to add them together?
Okay, so you've cut it 5/16 bigger.
Short, yeah. But can I make that root opening a 1/4 plus 5/16?
No, you cannot, because the detailer has already chewed up your 16th, correct?
No, this is one of those tricky things in the code. You can add those together. You could add that 16th to make it 5/16, and then because we screwed up and we cut our plate a little short, you're allowed to add that extra 1/4 in.
All right. So they've written the code, because most of this stuff isn't aerospace level criticality as far as dimensions. So they give you a little slop here in how they've written the code. What were you going to say, Pete, before I walked all over you? Sorry about that.
No problem. It was like, it's one of those tricky little things that unless you really read through all this. Now, maybe here it's nice. They've added where you can say C5411 and 5418. That might walk us through exactly what that our allowance is. But unless you really dive into the code and read through it, you may not pick up on those nuances of what that is. But you could get a little more tolerance out of something that way by adding those together, or if it's in the case of I don't think any of them are subtract. The detailer can always make it easier, but you don't want to be making it harder for the welder, for the craft to do their job.
There we've got weld joints. So you've got to cover base materials. We haven't touched on filler materials yet, have we?
No, we haven't.
All right, let's go to welding processes. I don't know if it's in a different place.
It is basically the same. The 2020, it's section 5.5 or clause 5.5, and the same processes are pre-qualified. SMAW, SAW, GBAW, except short circuit, and flux core WPSs. Those are all pre-qualified.
So why can't we use gas metal arc short circuiting, Pete? What is wrong with that process? Why is that the bastard stepchild of the welding?
So that is a great process. I can say I have put in miles of pipelines in thousands of feet of water with short circuit welding process for the root. However, in an uncontrolled way, you can get a lot of lack of fusion real easily. That is the big problem with it. It lends itself, it was originally made for thin sheet metal, where it has enough heat input to make the weld. However, once you start applying it to thicker materials, unless you apply it in a very controlled manner, you have a very good chance of getting lack of fusion along your weld. That is why it is the red-headed stepchild of the gas metal arc or MIG welding world. And people will argue all the time with me what they think is spray transfer, but you walk up to it and it sounds like bacon frying, which is the Cadillac symbol of, or telltale symbol of short circuit.
A couple of things with short circuiting. Number one, if they're using, you can't get spray if you've just got, it depends on voltage, amperage, and the gas you're using. So if you're using a 75-25, 75% argon, 25% carbon dioxide, you can't get spray. You cannot get a spray transfer mode. You could get globular, but you can't get spray. Anything under, generally I'll kick back a welding procedure, anything under about 20, 21 volts with, let's say, an 045 diameter hardwire, you're running in the short circuiting zone. And you go into a shop and you'll hear a guy running and it's like, nah, you're supposed to be running with spray. Why are you running with that? And then, well, how did you know? It's like, well, I can hear it. Pretend I've been playing this game for the better part of 3 decades. So it gets back to the fusion. And if you've been around short circuiting on thick sections, let's say you're in a cold environment, those welds will crack and it'll shear off just right along the edge of the weld joint. Thoughts?
No, I completely agree. It is definitely a where you can run into, when you do a bend, all of a sudden you're like, wow, this has a perfect little line right along it because you had a lack of fusion. And as you were saying, gas makes, you could never get spray, maybe globular out of C25. The Europeans use a lot of, I believe it is C18, and that is somewhere around, I think it's 1820 is the minimum or the maximum amount of CO2 you could have and still reach spray. But you're right. If what you see low voltages, low amps, and that kind of gas, you're not going to have it. So, like, let's say just for example, C20 with 035, you're looking at probably somewhere around 195, 200 amps to be in spray. 045 goes up even more. That's about like 255, 260 with that. Now, if you increase your amount of argon, you decrease your transition current. Like, let's say we go for 92.8 argon CO2, you're probably looking at for like 175 amps for 035.
So basically what we're talking about here, kind of breaking it down, is at a certain point you've got enough current in there where it's running through that wire, and there's enough current, electricity going through that wire where it just shatters the filler metal and it just turns it into little droplets, and it's like a little shower of weld metal going into that weld joint, and it is freaking hot. Whereas I would liken gas metal arc welding short circuit, it's more like using a glue gun, a hot glue gun or something. The wire actually goes down, touches, melts, breaks off, goes down, touches, melts, breaks off. Whereas if you're in the spray, if you're using the right gas and a high enough current density, it's just going to shatter that filler metal into little droplets, and it sprays and it makes this humming sound or a buzzing sound. You have to understand a lot of welding isn't just visual, it's understanding the sounds too.
I would agree. It's understanding the sounds, and if you can't hear it for whatever reason, look for spatter. If you don't really see spatter, you're probably in spray. Globular leaves a lot of spatter. Short circuit leaves a lot of spatter, but spray transfer hardly leaves any at all.
So those are the processes that are approved. There's other code approved processes: electroslag, electrogas, gas tungsten arc welding, and gas metal arc welding, short circuiting. You can use these with the code, but you have to qualify them. They're not pre-qualified. So you got to go and do bends and tensils and whatever code required testing. The code requires as far as testing for that process. So if you're using one of those processes, you're done here. Turn the page, go to the next chapter. Done.
Exactly. The other thing I want to throw out, and just so folks know about it, let's say I got an old Lincoln 200, great welding machine, stick weld around the world with that. The only problem with that is a constant current machine. I can't just go throw a suitcase on it and go flux core welding. For GMAW or MIG and flux core, the power supply has to be a constant voltage power supply. That is because those processes work much better as constant voltage or CV versus a constant current or CC. Like I said, this really only applies with either older machines or machines that were made strictly for, hey, this is a SMAW or stick welding type machine. Doesn't come up very often. Just so if you think you're going to grab your old Lincoln pipeliner that puts down a fantastic bead and everything with 6010 or 7018 and use it for flux coring, not qualified under the code. That's one caveat that while it doesn't come, like I said, come up very often, it is applicable.
Okay, we've covered welding processes, filler metals, and shielding gases. In the old code, it was base metal and / filler metal combinations. There was a table where that was covered.
Correct. So that table still exists. So they have matching and then undermatching relationship. That's how they split it up, the same way it was the previous code. Basically, all they've done is renamed it and renamed the numbering. Other than that, the only changes I'll say they have, Gary, is they've put in here to try to combat the whole short circuit, is they're linking a lot of the shielding gases back to the filler metal specification.
So it's basically telling you can't use carbon dioxide with gas metal arc welding. 100% carbon dioxide.
Exactly. They're fighting that whole and trying to prevent that from occurring.
So then you've got, here's out of the 2015, only base metals and filler metals listed in table 3.1 and 3.2 may be used in pre-qualified WPSs. For the qualification of listed base metals and filler metals, and for base metal and filler metals not listed, it's going to kick you to another table. So let's say you have a, go ahead, Pete.
No, I say no. You're exactly right. That's the same way this is. It's just changing. A lot of it is going to be changing it to like table 5.4. It's basically only is a revision of the clause number.
So it basically, if you go to that table, it tells you, okay, I can use E6010, I can use 7015. It gives me the electrodes that I can use, and it breaks it down into submerged arc or whatever. If you're filler metal, let's say you've got some super duper European filler metal that your client wants you to use, and that's the end of the story. Well, if it's not listed here and its supplier hasn't qualified it as a specific AWS specification, you can't use that material. You go to clause 4. You're done here in pre-qualified. Some Chinese welding material, it's just done. Go to clause 4, qualify it, and move on. Do your bends, your tensils, and go from there.
Correct. While it will not affect very many folks, but like weathering steel, if it's going to be exposed without coating of any kind, you have to select the correct kind of electrode that has the same kind of characteristics, and that would push you to table. In the 2021, it's 5.6. In the 2015, it's going to be 3 point something. But that's just one of those other kind of little caveat get you things where I've seen it was on a bridge job. It was a weathering steel bridge job, and they welded it with non-weathering electrode, and they had to paint it. That was a costly mistake to go from a uncoated bare bridge to a painted 3-coat system. So that's even though this is not D1.5, but it's the same kind of mistake though. If you're ever dealing with weathering steel, find out if it's going to be painted or if it's going to be left bare for its own patina to develop before you go like, well, that's a A588 or a A709 grade 50W. Those are all group 2s. I can weld them with this 7018 hammer down. Well, not for that weathering steel. You'd have to go to like an 8018 C3 for a stick rod example. But like I said, that could be a costly mistake for someone.
Okay, here's one that trips people up, and I don't know what it's numbered in 2020. Engineer's approval for auxiliary attachments. I've seen people play with this one. This is where engineer's approval for auxiliary attachments. Unlisted materials for auxiliary attachments which fall within the chemical composition range of a steel listed in the table may be used in a pre-qualified WPS when approved by the engineer. An auxiliary attachment to me is a non-load bearing clip or ancillary item in the structure. And if let's say you're putting on something that came from Upper Volta or Serbia or China or whatever, and the part was made with their steel, and you look through the chemistry for that steel, and it's like, this stuff's close enough. It matches up with A36. Let's say it's a German steel. It matches up with A36. You write a little piece of paper. Hey, I did the comparison. I've done this a few times when I was at the Hanford nuclear site. I'd go through there, find that steel, find a comparable American steel, do a comparison, say this stuff kind of is similar to this material. I'd write a little piece of paper, sign it, send it to the engineer. Life's good. Thoughts, Pete?
No, I think you're on track. Where I have seen this mainly used to write is like on welding electrical boxes to structural framing. That is where I've rented this the most, where it's like, I don't know, it's some kind of little box. You buy them from the supply house. There are a whole bunch of them. We have 1,000 of them that have to get welded on. It's like a little, let's say a 16th inch fillet. And it's like, do we really need to qualify it? It's just to hold, for whatever reason, they want to hold it on, and the engineer says, that's fine. We don't need to go through a full qualification riggable roll for holding on an electrical switch box or something like that. That's the place I've seen it mainly used, because for what they're saying is it's auxiliary. It's not really like load bearing or structural. It has to just kind of hold itself up. It has to basically glue itself on without falling off. That's the gist of what I found that. But yeah, that's up in the base metal one that we covered a little bit ago. But you're right, that's a very good point, Gary. I'm glad you remembered that.
Yeah, and I'm kind of operating off a little different script here, so I'm kind of hitting some stuff. Preheat and interpass temperature requirements, how deep you going to go into that?
Well, all right. So minimum preheat and interpass temperature. In the 2020 version is table 5.8. I don't remember what it is in 2015, but it basically lists out the materials by group for their minimum preheat based on thickness. That they're pretty self-explanatory. So the way 5.8 or the previous version, which is going to be 3.4 from memory, it's both of the tables are broken into an A, which is the distinction with A. It has a handful of materials listed, and it's SMAW with other than low hydrogen electrodes. That's your 6010s right there.
Right. So you've got a part of the table, and it gives you a preheat temperature. And then You've got, if you're using a low hydrogen electrode, then it's got a little bit lower preheat temperature. But you'll notice as you go, if you're welding thick material, okay, if you're over 2.5 inches thick, you're at 300 degrees with non-low hydrogen material, and then you're like at 225 with the low hydrogen material.
Exactly.
You're still gonna be cooking that thing.
You're still going to be cooking it. But where it affects people the most and where they make a mistake at is either they look at table A while they're using filler metals for material B, or that would go into B. So you're spending money to heat stuff up when you may not need to, because for 3/4 and less, the tables are the same. It's 32 degrees or higher. But once you get over 3/4 of an inch, if you're using 6010s, it goes to 150 degrees, while in the other, with a low hydrogen 7018, you're at 50. That is where, and especially in the structural world, that's kind of the thicknesses a lot of times you play in. That's where people either be spending money where they don't need to be, or they're not doing what they need to be. But as we talked about in the other ones, as the materials become stronger, your preheats will increase. So you got your A, as we already said. We have a B. B's a long table for that portion. And then we go to C. And C are your higher strength materials. They start ratcheting up in temperature quickly. D is a little different one. One is it limits you to an H8 electrode, which is 8 milligrams of hydrogen per 100. Commonly you'll see a lot of this. A lot of your flux core wires and your stick rods will all meet an H8. Your solid wires will definitely be higher than this. But here, this one's a little different. It's only 32 degrees for D. E is also very similar as well. They only have 2 temperature combinations. I have never actually dealt with any of these materials here, so I haven't had to deal with them. Have you, Gary?
No, I've never swam that deep in the pool. Like I say, most of the stuff I've dealt with was A or B.
That's right. I have not dealt with, but I mean, these materials can't be very. I mean, if you can have over 1 inch and 120 degrees as your minimum, either that material is not available in very thick sections, or it is a super weldable friendly material. Now here's a question, Gary. What is the difference between interpass? Because I have minimum preheat and interpass. What's the difference between those two? Aren't they the same?
Minimum preheat is the temperature that you have to reach when you start to weld your first weld. And then an interpass temperature, I can't strike an arc until my interpass is that temperature, correct? What am I missing?
No, you're going down the road. So your preheat, you're right. You got your 2 pieces of plate you're gonna weld together. You need to preheat them. So you're heating them up. You got, like either your rosebud or your pear burner or high class with like resistance or induction heating. You're heating it up. Let's say it's a 3-inch thick plate, and it's a 3-inch thick 836 plate, and you're welding it up with a low hydrogen electrode. So you're looking at minimum temperature of 225 degrees. That's your minimum preheat before you start up an arc. You heat it up to that, and then you start welding. You put the first pass down, you come back, and let's say your grooves, your plate's 8 feet long. It takes you a while. So when you come back to it, your interpass temperature is the temperature it has to be between passes. So if you come back to the end and, wow, this ends at 100 degrees, but where I was welding was like 400 degrees because it was hot. I was welding on it. So if it's 100 degrees on at the beginning and my minimum interpass and preheat was 225, would I be allowed to weld, Gary?
Preheat and interpass temperature is you don't strike an arc unless it's that temperature at a minimum. Whether it's the first pass or the 37th pass, you do not strike an arc on that material until it has been heated up or is that temperature at a minimum where you are going to be welding. Like Pete said, if you're at the other end of the 12-foot long weld and it was 400 degrees down there, and you come back and it's
100 degrees
or 80 degrees here, you can't
Yeah.
strike an arc until you heat that back up to the minimum preheat and inner pass temperature. It's the temperature that you can strike an arc at.
Yep. No, I exactly agree with that. The one thing that's funny, or that I found interesting about D1.1 is there's no maximum temperature listed.
Yeah, I think part of that has to do with a lot of this stuff you're welding on bigger material, you'd really have to put a lot of heat into it to get it that hot. You know what I mean? There's a lot of
Exactly. No, I agree. It would be hard to get it hot enough. But
from
if you had
thermal energy. You know what I mean?
no, I know, I agree. But if you have a smaller part, you may build up real quick. And what I have used in the past is 600 degrees Fahrenheit is my maximum temperature, because I feel at below 600 or 600 and less, you're not going to overheat the material. It'll be hot, but you're not going to overdo it for most uses for the materials listed. That's kind of been my unwritten rule. I also see 450 and 500 also commonly written in as well.
Okay, so that gets us through preheat and inner pass temperature.
Well, one thing what about different base metal thickness combinations, or different, if I got let's say be a B to a C, what do I got to heat it to? Or if I have like a quarter-inch plate welded up to a 2-inch thick plate.
My interpretation is I've got to go to the minimum temperature, the highest requirement. If I'm welding a B material to a C material, I have to achieve at a minimum the C material preheat temperature.
Exactly. So if, let's say, I mean, it was, just making up numbers, it was a 225 degree requirement for your thick plate, you would also have to apply that to your thin plate. Now, there has been arguments about this. I know where it's, why am I preheating a quarter-inch thick plate to, let's say, 225 degrees? If I'm welding it to a 3-inch thick plate, that's 225 degrees. It's not going to draw out that much heat. I think it's a valid argument. Unless you really know what you're talking about, I don't think I would make that argument or do that practice.
All right, so we done with preheat and interpass?
I think so. The only other one that's, and I've only ran into it a couple times, is when you're dealing with sub-arc, because when you have a bunch of wires or you have multiple wires in it, your arc heating up is so much that you can reduce your preheating. But like I said, this is a unique situation that is not common, so I don't think we need to delve into that one at all.
Okay, so we've got Part G, WPS requirements. So this is where a lot of people get tripped up when they're writing a WPS, is they get into the WPS requirements. I'm running out of 2015. So general WPS requirements. So this is 3.7 in 2015. So it's going to kick you to, is it still the tables in there, Pete?
Yeah. So what it will do is in 2020 it's 5.8, but everything is almost the same except one place where it says, yeah, table 5.1 is where it limits everything. But other than that, it is, I imagine it's identical to the 2015 code.
So a lot of when we're writing these pre-qualified weld procedures, you need to really be knowledgeable about these tables, because these tables will trip you up. So if you look on, Pete and I are kind of bouncing back and forth. Table 3.6 in 2015 is pre-qualified WPS requirements. And this is going to tell you the maximum electrode diameter. It's for each process you use. For stick, sub-arc, gas metal arc, and flux core. Maximum current, maximum root pass thickness, maximum fill pass thickness, maximum single pass fillet weld. You need to address all of these questions in your WPS. You need to go through here and find your process, and you just go down there. Okay, I'm going to weld in the flat position with shielded metal arc welding. My groove can be 1/4 inch thick, or I can only go up to a 5/16 inch fillet weld in the flat position, or not, excuse me, I can only, in the maximum electrode diameter for shielded metal arc welding, I can have a 5/16 fillet weld, or in the flat position, I can use 1/4 inch, or you just go through here and just start checking boxes for your process. And then the other table is for the pre-qualified WPS variables. So you go down there and okay, change in welding process, change in welding positions. Okay, so if I getting back to the theory, if I'm writing a WPS, I might not have my overhead WPS and my flat position WPS in the same on the same WPS. I might write them as two separate WPSs because they might.
You're right, because the variables could be different.
And maybe if you're skilled enough to write it, you write it all in one. But sometimes it's beneficial to write them different. And then even if you do use the wrong one, it's an easy paper out of it. Okay, we're still using 7018. He did this and this, but we're going to do our QC department, we're going to do an NCR on this. We're going to slap some hands. Everybody gets a slap on the wrist. Use the right procedures. Get your paperwork together. But you haven't done anything structurally wrong. You didn't use the wrong filler metal. You didn't put it in there with, a stainless filler metal or something like that. For the most part, as long as your filler metals and your preheats and most of those things, most of those variables are covered, you can get away with some stuff if you're writing an NCR, a non-conformance report. This is kind of my theory on, WPSs. I run into customers or I guess clients and people I've dealt with, and they want to just have one WPS, and it's like, just bite the bullet, write a couple, 3, 4 of these, build yourself a library, and go from there. You want to swim in the big kid end of the pool. There's certain things that you're probably going to need to do, and assembling a weld procedure library is one of them. But go ahead, Pete. I know you want.
Well, also remember the whole goal of the WPS is as a set of instructions for the welders. So it needs to be something that they understand, and can provide guidance. Like the one I always hated, and I'll be honest, in probably the beginning part of my career, I probably didn't really think about it, but where we look at, like, let's say maximum current, and for a lot of them it says, let's say for SMAW, within the range of operation recommended by the filler metal manufacturer. Do you know what? They might recommend 100 to 500 amps. If you put that on their WPS, are you wrong? Maybe not. But what good are you giving your guy in the field? I mean, I can see a welder on a bad day that his foreman hacked him off, being like, well, let's go set that machine for 500 amps. And he just burns through everything. And the foreman comes over, what's going on? Like, well, I followed your WPS. I'm at 500 amps. That's not the intent. That's not what they wanted you to do. But you need to bracket it down. I mean, where it makes actual value for the welder. I mean, some of them may be really good, know exactly how to set up their equipment. Other guys might not, or gals. I mean, they're maybe new to the industry, due to this welding machine. They don't have a little tick mark where they've had really good success on written on the dial. I mean, a lot of places operate like that. So we need to make sure that the piece of paper is worth what it's written on. It could tell the person what they need to do.
Well, and just because it says range recommended by the operation of the manufacturer doesn't mean you can't clamp it down and say,
exactly,
nope, this is how many. I know other people put this many chocolate chips in their cookies, but I want 7 freaking chocolate chips in every cookie. I don't want 9. I don't want 13. I want 7 freaking chocolate chips in my cookies. And that's kind of how you have to approach it. And 90% of the people welding aren't going to know that this is in there, and look it up. Oh, I could be running this at 500. No, engineering judgment says this is where I want it run. Maybe I'll give you a little slack on that, but this is where we're going to run with it. So
exactly. So what I have found is what I'll do in a lot of welding procedures, and this is also why I like Excel. is I can put on, this is my preferred range of parameters, and it might be a pretty tight box where you have to be within, but then I'll have an allowed range of parameters that's bigger, that sometimes when you get in a corner or something, you might need a little more amps or where, so you need to push the dial a little bit, but you're not outside of your procedure. So that's my spin on how I handle that right there. Even on qualified procedures, I'll look at doing it the same way. A preferred and an allowed range.
And see, philosophically, I don't know if I'm not saying Pete's wrong on that, but I generally go a little wider strike zone than that. I give them like enough rope to hang themselves. But all right, I want you guys operating in here. I don't need 7 chocolate chips, but I need between 6 and 11. You know what I mean?
Exactly.
And it depends on what your workforce is, your guys, who you got for, you know. And we've got another episode we're going to talk about. We're going to go off on some rants on setting up a welding program and training welders, and we're going to go into some rabbit holes here. But we're not doing it right now. But a lot of this stuff ties together. So, you know, that's one of the things you got to look at is, like he said, you know, the maximum current. If you go down here to that next table with the pre-qualified, you just go through here. If you're submitting a weld procedure for review, always check these 2 tables and make sure you have everything addressed. I'm one of these guys. Every time I review a procedure, I go to these and I check your stuff against them. Missing this. Nope. And I'd have little text files where if you sent me a PDF, I'd just put it in there. Fix this, and I'd have the relevant code sections to it. So, and you need to realize that not every welding process has the same variables, obviously. There's no wire feed speed in shielded metal arc welding. There's no flux type in gas metal arc welding. So you need to go through there and just check all the boxes and make sure that you've addressed everything. You know, like thermal, a change in post-weld heat treat, addition or deletion of. I will gig you on this one if I review your stuff. Even if you're not doing post-weld heat treat, put none. We're not doing it. So that tells the welder there's none. Not applicable could be we're doing it or we're not doing it. So make sure and address everything. Addressing it just means filling out that box and saying none, or yes, we're doing it, or we're putting in 14 chocolate chips in each freaking cookie, whatever. You need to address it. So thoughts on this and reviewing it? I know you've reviewed a number of procedures in your day, Pete. People cry.
I basically try to do the same thing. I think I may have a little more leniency on the one that you just picked on, post-weld heat treat. Post-weld heat treat is rarely done. Well, I'm going to say rarely. It's not commonly done in the structural world, and I've basically kind of looked at, if you don't say like, and you give me preheat or post-weld heat treatment instructions, I'm assuming you're not post-weld heat treating. Maybe that's exactly right, but I've kind of looked at it from that standpoint. But otherwise, Gary, you're right. I basically go through and do you have the essential variables, essential and non-essential variables checked off for your applicable process. And that's also what goes back to what we were earlier saying is mixing in a whole bunch of stuff on the one WPS leads you to more chances of failure or of forgetting something, or not switching between like electrode positive or electrode negative, depending on
you still there?
Yes.
All right. Yep. You still there?
I'm here. I can hear you fine.
All right. You kind of cut out for a minute, but all right.
Where'd I cut out at?
I think right before you went into you were talking about electrode positive, electrode negative,
okay.
kind of.
All right, all that got cut out, or right after it.
Right, kind of in there. So if you want to digress, then I'll kind of cobble it together. Check.
We
Go
have
ahead.
multiple WPS or multiple processes on one WPS, you can run into more problems of where you have addressed variables for one, but maybe not the other. But yeah, otherwise, Gary, I completely agree with you. Going through all these, making sure you have them down, is how I review a welding procedure. Plus, with the gut check factor of, hey, does this make sense?
Right. And well, part of it's where, everybody learns I guess I cut my teeth and I learned the religion of welding out at the Hanford nuclear site. That's and I mean, those guys would go through everything with a fine tooth comb. And I mean, it was just a brutal slog on everything. You got guys out there that have been doing things for 30 years and it is verbatim compliance. So that's why I'm maybe a little more zealous on things. But generally, if I go through somebody's weld procedure, and I'd tell this when I was working in the Midwest, I'd tell guys, if I go through your WPS and you fix everything on it, there's nobody else going to mess with you later on. It'll be watertight if you fix everything that I tell you to fix. So, I mean, it's kind of a double-edged sword, but, take it as a learning experience.
Exactly. I agree. Everyone both writes and reviews welding procedures from a little different angle. So as you alluded to earlier, if you know the reviewer, you know what their pet peeves are. There's some people like to see lots of notes on it that may correlate to the joint detail, while other ones are, hey, just call it the joint detail and you're good to go. I'll be honest, my pet peeve is, will it work for the guy on the shop floor? That's my, I guess the way I look at it is it understandable? Where, like, let's say base metals, if someone puts down, hey, group one, let's see, would be, yeah, group one materials, or class one materials. Do they have a D1.1 code book out there to know what a class or that group of materials is? That like a group one or a group two? That's kind of one of my pet peeves. Is rarely is a code book ever on the shop floor.
Well, and my other one is, if you write a weld procedure and you put A36 to A36, that's it. You can weld
That is
A36
it. The
A36. A36. Welder, we were welding a group one material. Nope, you should have said group one to group one. There's ways to word this, but if you say specific material to specific material, that's the end of it. You can weld that with that procedure. So there's ways to write that. Getting back to what you said, Pete, too, about like writing and reviewing procedures. A lot of times you'll have intermediaries, sales or document control submitting your procedure to the client, and then there's a client person getting it, or to the client, and then them getting it to their welding guy. A lot of times when I'm doing these, I just tell the intermediaries, well, their welding guy kicked us back and it's all marked up. And I'm like, just get me that guy's number. Just get me the guy's number. And I'll call him up and be like, all right, what is it you want? This is who I am. I kind of, give them a preface of who I am. All right, I worked at Hanford, blah, blah, blah. I'm a welding engineer. Kind of, give them my short resume. What do you want on this WPS? What's the hang up? And a lot of times they'll tell you, and I'll be like, all right, I fixed it. Send it to them, and they'll tell you, oh yeah, that's great. There's a lot of this back channel stuff and we're kind of getting off into the weeds here, but this back channel kind of stuff works good. Or let's say I've worked with Pete before. We haven't crossed paths in the professional world since, as far as me reviewing his or vice versa. But if he sees that I'm the reviewer, he's going to call me up and say, Gary, what do I need? What do I need to get this through? What's your pet peeves? Or I got a pretty good idea. This is what I'm looking at. What do we got to do? So
exactly. It's hard to build a rapport when you've either never met the person, or it's pure communication through paper. I feel the humanity is lost when it's just a paper conversation, uh, where you may not understand, the person may know or think some other specification or something applies when it doesn't, and it's, oh, now I understand your point of view. Now I understand why you wrote it like this. Let's try to make it right, or uh, address whatever the missing details are. I agree. Always try to get a hold of whoever is the ultimate approver and talk to them. And when they know you're a living, breathing person, things seem to go a lot easier.
No, and like you say, if I had a guy tell me, a project manager, he's like, the hell is it with you welding guys? He's like, every time, if you haven't worked with the guy, every time with you guys, it's a goddamn fight. You guys have a fight, and then once you guys figure out, oh, the other guy knows what he's doing, he kind of has a clue, then you can kind of figure it out and work together. And then, but until you guys have your fight and figure out who knows what, the project doesn't go anywhere as far as welding WPSs and PQRs. So that's kind of the way and not that you have to have a fight, but I was dealing with a guy from Ingalls Shipyard, and he rejected a bunch of our stuff, and I was like, give me the guy's phone number. This was when I was working up out of Seattle. I was like, give me the guy's phone number. I call him up, nicest guy ever. He's like, yeah, fix this, and this, and you're done. And I'm like, all right, I'm going to change the WPS number. I'm going to modify this. This is going to be just for your job. I'm going to send it down there. We kind of exchanged emails, 2 emails back and forth. We talked to each other. All right, no problem. But we were going through sales and then his purchasing, and they were getting involved, and it was just this whole email string, and it's just like, just let me talk to that guy. We'll hash this out. So, all right, let's reel it back in. We'll hit post-weld heat treatment and call it a day. What do you think,
All
Pete?
right, that sounds great. All right, post-weld heat treatment. Uh, like I said, is not common in D1.1. It is allowed. Uh, the one of the things is it's pre-qualified, but it has to be approved by the engineer. So there's a little bit of a caveat. It's pre-qualified, assuming you follow these 5 steps here, but it has to be pre-approved by like I said, by the engineer. There's some simple things on here. Base metal strength can't be over 50 KSI for the yield. It can't be a quench tempered material, or Q&T, or thermomechanical processing, which we got to be careful about that. There's a lot of plate out there that's now made by the PMPC process. And what I would look at is the actual MTR of the material that you want to use. Because in an ASTM, it may give you, it could be done by this, this, and this. Well, you need to look at the MTR for what your exact material was done. There's no CVN requirements. You have the filler metal has to have showed adequate strength from the A5 filler metal spec. And it then also throws you, in the 2020 version, it throws you to 7.8 for some other requirements for that you have to do the post-weld heat treat in. I think in all of my years for doing D1.1 work, the only time I can remember it coming up was, and it was actually, the welding procedure was qualified, but it's still D1.1 post-weld heat treat, it was a massive bascule bridge, and it was the rack gear that goes on the bottom. It was like 12 inches thick. It was welded to a base plate so it's like a 12-inch thick plate that's like 5 feet tall, welded to a base plate that was 6 inches thick and let's say 2 feet wide, I don't know, 8 feet long or whatever. It was welded and post-weld heat treated. not for the weld. It was to stress relief the base material so it didn't move during machining. Uh, that is I think the only time I can really think of as post-weld heat treating on structural steel that I've dealt with, Gary.
I've never come across it. You run across post-weld heat treatment in power plants and boilers and HRSGs and castings and a number of other situations.
Yeah, oil and
Turbo
gas is real
casing.
big on, 4130 goes all over the place. That's all post-weld heat treated, but structural steel, there's just not the need for it.
No, it's pretty much just plug and play material. The mechanical properties are going to be what they are. So
Correct.
I guess wrapping this up, a couple of keys is there's not a lot of verbiage in here. There's like 3 or 4 pages on pre-qualified,
Correct.
But the tables are where you need to understand the tables, and the 3 or 4 paragraphs in here that are very powerful, and they will kick you out of here and send you into the qualification zone.
Exactly. Like your cookie chip correlation. I mean, if you have to have exactly these cookies chips to fall within pre-qualified, or it kicks you out. And I would say knowing table 5.1 these numbers are all out of 2020 is 5.1, 5.2, your 5.3 table, and 5.4 is just matching filler metals for the different base metal groups. Those are going to be critical for.
So your table with your base metals, your preheats, your filler metals, shielding gases, understanding weld processes. These are all things that will trip you up in the pre-qualification. So I think we did a pretty thorough rehashing of this. We might have to break this one into 2, but anything you need to say in wrapping it up, Pete?
There was one table that, just so folks know about it, in 2015, it's table 5.5. I'm assuming it was 3.5 in the old, in the 2015 code. And this is minimum pre-qualified groove size for your material. So basically it gives you a range of base metal thickness and then the minimum weld size that goes along with it. And basically the thicker the material, the bigger the minimum weld size. So that's just one to kind of know about its existence. So it doesn't come back and bite you on something.
All right. Well, we'll leave it there. Hopefully we haven't put too many people to sleep. Or if that was your intention, hopefully you got a sound sleep while this was chasing off your insomnia while we delved into the pre-qualified WPS. Okay, next time we're going to dig into qualification. We'll start down that rabbit hole, see if we run into Alice or the Mad Hatter or see where we go on that one. So, all right, thanks a lot, Pete. We'll talk to you later.
Take care.
Right. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal, throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry Pace Welding ASME or AWS D1.1, there's a bunch of videos on there. Check those out too if you're interested.